For this part of the tutorial, we will develop the living hinge grasshopper definition. Now we've identified the faces that will require the living hinge grasshopper definition in order for us to bend plywood. We have item 3 and item 1. So let's copy and paste these components. Control C, Control V. One. Item 3 and item 1. To extract the information we need regarding this face, we use Surface tab, Analysis. We'll again use the Deconstruct brep. Again, the results will give us a list of faces. For this item, we have one face, 4 edges, 2 curves and 2 straight edges, as well as 4 vertices that define this face. To extract the curve that runs along the edge of this face, we'll need to use another item list, Sets, List, Item. It's very difficult to see what we're selecting as there are several geometries in the viewport. So what we'll do is use a pipe component, so Surface tab, Pipe. Now let's use a number slider to scroll along the list. Let's say 2. Select pipe so we can see exactly what edge it's referring to. Okay, so it's item 1 in the list. Now what we'll require is the exact length of this curve. So let's go to Curve, Analysis, Length. Excellent. We'll no longer need the pipe, so let's de-preview this. Now it might be helpful for us to move these shapes that we see in the viewport, shapes that are ready for exporting. So let's go back to our shapes that are ready to be cut. Here we go. Select. Now let's look at this series component. This component refers to the series of points that we use as placeholders for these shapes. So we can alter where the series of points commence. So let's bring down a number slider. 12. This would allow us to move the shapes across the page. Great, perhaps just there. Now these shapes are ready to be laser cut, to be exported and laser cut. Let's go back to our living hinge. So we have the length, we've extracted the length of this curvature. What we like to do is create a rectangular length that represents the face of this curve as we unroll it onto the flat surface. So with this length, we'll create a simple line. So curve, primitive, line SDL. Line SDL will allow us to create a simple line across any vector direction. So in this case, we simply need to create a line that represents the length of the face of this surface. Start point, let's create. So let's go to Vector, Point, Construct a Point. Great. Now the direction, we'll simply put X. So vector, vector again, X. Now the value of the line length is what's critical. We'll feed in the exact length of the face. Excellent, now it's there. To view it, let's simply use this pipe component to see exactly what we're viewing. Excellent. Now how about let's make some space for this shape, and best to move all the other shapes that are ready for export further across. So let's go back to our series component and let's alter this, move it across the page. Excellent. Let's go back to our living hinge. Now let's de-preview this pipe. We just use this pipe component for viewing purposes. So preview, de-preview. So now that we have this line, we basically need to create a rectangular shape that represents the face of the side of the S that requires the living hinge. So simply let's move as well, doesn't just move the actual geometry, it copies the geometry and moves it anywhere in 3D space. So simply let's move this. You'll find that it's not just moving it, but it's creating another separate line segment. So move, asking for translation vector. Let's go to vector, vector again, y direction. Great, there it is on the page. Now to represent the exact thickness of our three-dimensional S, we'll need the exact value we used to extrude this geometry. So let's go back. Here's the extrude. Excellent. So thickness is 4.5. We'll need that exact value. Great. As you can see, as you change the values and the thickness of this geometry, the new line dynamically moves. Okay, great. So now we have two lines. Initially this. So we still have the original line, the new line segment. Okay, from here we'll have to break it up. So curve, division, divide the curve. Excellent. Let's copy and paste this component. And divide the original curve. Great. So we have division points of the original curve and division points for the new curve. Now what we need to do is create a line segment that connects the first set of points to the second set of points. Okay, so curve, primitive, line. Original set, A. Second set, B. Great. Now at this point there are different ways of creating the living hinge pattern. What we'll do is, now that we have a list of, again, line segments, we'll simply create two lists of alternate line segments. So let's go to sets, sequence, call pattern. Great. Now let's use a Boolean toggle. So double click on the page, toggle. Great. Copy and paste. Great. So let's change this, double click on the first one, so we're changing it true and false. Basically we're creating a pattern of selection. So we're basically selecting alternate line segments. So let's feed in the pattern into the call pattern. So by default it's giving us 2 false and 2 trues. In this case we're defining the pattern ourselves. So let's feed in true. Hold down shift. And feed in your list. Great. Again, it's very difficult to see unless we use the pipe component. Preview. Great. So here it is. We've created, we've selected every other line segments. Now we can increase the division points of our pattern. In the divide component, we can use a number slider. Excellent. Now, to create the living hinge pattern that we see here, we'll need to break up the line segments that we've just selected. Let's depreview the pipe. Excellent. Go to curve, division. There's several ways to create the pattern. I'll simply use a dash pattern, or you can also use shatter. In this case, I will use a dash pattern. Now C asks for the curved, or curves in this case. Hover over pattern. It asks for number parameters. The numbers must represent the length of dash and the length of gap. So let's bring down number slider, say 1.20, and copy and paste. Great. Hold down shift. Excellent. Let's depreview some of these lines off. Let's depreview these points off. Now for this, we'll simply select the output of dash line segments. So let's go to parameters, geometry, and we use curve or line. Let's do a tidy up. Excellent. So this is our original list. Let's copy and paste this section, Control C, Control V. Great. Put that across there. Now let's change the pattern around, so false and true. And in this case, we'll select the gaps. Preview. Excellent. Now it depends on how much curvature you need to achieve. You may need to increase the scoring of the plywood, meaning you'll have to increase the count of these line segments. So go back to your divide components and increase the counts of the line segments. Excellent. You can adjust your pattern. Great. Excellent. Okay, so these are the faces that are ready to be laser cut. We have the planar S shape, another planar S shape, and the ends of the 3D geometry. Now we have a living hinge pattern to follow the curvature of your three-dimensional S. Actually, the ends of this must be enclosed. So let's go back to our original length segments. We have this and we have the move, so we'll simply go to curve, analysis, endpoints. So endpoint for that, great. And another endpoint for the original line, excellent. And let's start and another one, copy and paste. A, B. So what are the critical lines? Let's bring back our pipe component. So what do we need to laser cut? We need this original line, great. This second line, excellent. And the end lines, 1 and 2, as well as the pattern we've just created. So we need those and we need those, great. So let's make sure we're exporting the correct geometries here. So let's just depreview again this pipe component. What I'd like to do is connect some of this curve. So go to Curve tab, Utilities, and Join Curves. So let's join the original line, great, one end line, third, this join component now represents the shape of plywood we'll need to cover the side of our S. So let's depreview all of these components, select, right click on the page and preview off. Excellent. Now let's bring this across in line with our other two. Depreview this. Now this is the definition we require for the first curved face of our 3D letter S. Let's just group them together, right click onto the canvas and group. Great. So for this, we need these. Now for this living hinge pattern, just take note, you can create some logic behind any of these input values, so you wouldn't have to manually adjust these patterns. Okay, so let's copy and paste this entire definition. Control C, Control V, and we'll move it above the page. Excellent. Okay, now we need to do the exact same thing for the other curved face. So that was the definition we created for the first curved face. With this entire copied definition, we'll simply plug in this item list. Okay, you'll have to make adjustments. If you have a look at the resulting geometry, it's obviously referring to a different item in the list of edges. So we'll need to scroll through this index. There we go. Okay. Okay, so what we need to do is move this, perhaps push it up the page. So let's go to, again, our reference point. Let's find our original line segments. So we have this. Now the point at which it occurs refers to this construct a point component. So let's alter the y value so we can push it up the page. Instead of the default 0, let's bring down a number slider, say 12. Okay, great. There we go. Okay, great. So that ends our tutorial for the living hinge. Now we should have a complete definition for laser cutting the shapes we'll need to fabricate our three-dimensional S.